Thank you very much. So first thing was I looked back at this title and I thought, my God, that's boring. Why did I write that? So this is what I'm actually going to talk about, which is a package manager for Python that I've come across in the last few months, and I thought it'd be worth sharing some of the things there. So as said, yeah, I've got background in Earth observation, lots of open source geospatial stuff, land cover, vegetation ecology, that sort of thing. But generally, come and talk to me about anything interesting. I just like new stuff that's useful. So I came across this because for the last 12 months or so, I've been working with a small software development consultancy, and all of their software developers had found UV and had moved to UV, and I was like, interesting. I'm not a software developer. At best, you could say I was a geospatial data scientist. And I thought, well, if it's good enough for them, it's good enough for me. So I downloaded UV, I installed it. I got nowhere because I'm not a software developer and I didn't really understand what I was doing. So I thought, maybe there's something else that's more akin to what I'm used to, which was conda and Mamba. So I started looking into things and came across this post, which basically says that there are too many Python package managers, which I will agree with. So the post mentions 11. This was written, was it last year? So it could be even more by now. Who knows? And it sort of mirrors that whole standard situation of, hey, why not just get another one and keep adding to all of the different package managers that we have. So the issue that I have, and I'm hoping that some of you might have as well, is that when you're looking at trying to manage Python packages, it can all just become a bit of a tangled mess. So you're trying to balance things like Python versions, you're looking at GDAL, spatial databases, things like that. Drivers for different systems, whether you're on Linux or on Windows or Mac. And what you really want to be able to do is have something that you can pretty trivially reproduce. So if I created an environment, I could just chuck it out to one of you. You could just go, get it up and start running and know that you're running exactly the same as me. So some of the big challenges are around some of the sort of the big libraries. So GDAL and the way it's packaged can cause some issues. And also looking at cross-platform differences. So I've already mentioned that I might be developing on Linux, and then one of my clients might be on Windows, another consultant might be on Mac. I'm just trying to get those all things balanced. And then integrating with other languages such as R, and I'll come back to that later on, as well as trying to make sure that when you're trying to balance out the packages that you're pulling in, that you're not wasting too much time and stuff like that. So as I said right at the beginning, there's lots of various options. Some are relatively simple to instantiate and to use, but they might be sort of slightly weaker in other areas, and some are quite powerful, depending on your point of view, conda, Mamba, but they're quite slow to try and solve the dependencies. In fact, like anyone who's used conda, it takes forever. So there are various limitations, and sometimes if you're sharing your code and your environment, then the workflows break, and some have a relatively steep learning curve, as I found through looking at UV. So could Pixi be the answer? Probably not, but let's hope so. So it's very lightweight and it's very, very easy to install. You basically have a script, or at least on Linux, you have a script, you run the script, it installs. Everything seems to just work, which is nice. And it's designed specifically for reproducing environments and being able to share them. And it's also designed for speed, and it is very much faster than anything else I've used in terms of working out dependencies on packages and then installing those packages. It's one tool that looks at the Python version that you're you're installing, but also all of the other bits and bobs as well that I've mentioned. And it's built on the conda ecosystem, but it's written in Rust and is a lot faster. So, I mean, I've taken this from the Pixi website, so it's obviously going to come out with Pixi is brilliant and the best. But it's quite interesting in that it shows you a comparison with some of the other things that you might be used to. So, for instance, I've mentioned conda and UV on the end as well. And this idea of lock files is quite interesting, and I'll come back to that as well. So once it's installed, it is really easy to use. So all you have to do is go to the folder that you want to put a project into, do Pixi in it, and if you want to, you can do a project name, and it just throws up a template project basically with all the bits and bobs that you need in there. If you are getting a configuration file from somebody else, then you can do Pixi install, and it will use that configuration file to create an exact replica of the environment that that person has. And it's a YAML file for good or for bad. So you can actually go in there and it's all human readable. You can see what it's doing. If you want to see all the packages that are in your environment, then you just use Pixi list, and it does quite a nice job of highlighting in bold the packages that you've asked for in your configuration file. So they're the ones that you've installed, and then all the other dependencies are listed there as well. But you can see which ones that which ones and which version you're actually looking for. And then if you wanted to add a package, so here we're adding anything greater than version 1.8 of PyTorch, and also pandas, and it'll just sort out the version of pandas. So you just do Pixi add, and then whatever it is, the package that you want to do at the end. So you can also set up within the configuration file things called apps, which are basically commands that you might want to run. So again, it's tasks, not apps, tasks that you might want to run. And that again is very useful. So if I had some workflow that went through a whole series of different modeling stages, the person that I would send the configuration file wouldn't necessarily need to know about the workflow or the modeling stages. I could just say, okay, run this task. So it'd be Pixi run Al's wonderful model. And then that would just run through everything that was in that workflow and give the answer or the command line or whatever it is that is needed at the output. And then if you need more interactivity, you just go Pixi shell and you can drop directly into that environment and start using it as you would any other Python environment. So there's a few things to know about being able to get going on a geospatial side of things. So you can install GDAL and all its dependencies in one command, just Pixi add GDAL and libgdal-core. That gets everything in there. All the dependencies and everything's up and running pretty much perfectly. Other things you might be interested in is looking at Arrow and Parquet and that type of things if you're into sort of larger data sets. And then, yeah, you can share the pixi.toml and the pixi.lock files with team members, and they'll be able to basically throw up exactly the same thing. So I've mentioned this pixi.toml configuration file a little bit. So it's broken down really simply into a few different things. So you've got information about your workspace here. So you can add different authors in. You set out the name of your project, what platforms. So you can add in Windows and Mac as well on there. And then just keep a description and about what it might be about. This is what I was talking about in terms of tasks. So here, we would just do Pixi run lab, and that would open up Jupyter Lab instantly in the same environment and with the same data sets and everything else that you have run your Pixi instance in. And then this shows the various different dependencies. And if you wanted to change anything, you could just come in here and edit the file to specific versions if that's what you wanted to do. So as I say, that's what configures Pixi. And then all of that, when it gets thrown up into an environment, gets written into a lock file. And it's that lock file that has all of the specific dependencies written in there for each of the different OS types that you might be using. So you can share that lock file as well, and that helps with reproducibility. I'll be honest, I'm not big on knowing what solvers are or do, but it uses Rattler, which is something that is, I think, written in Rust to solve for the dependencies. And it, so far, from experience, seems to be very fast and very reliable. And it means that we can share across different OSs. It also works with different languages, so you can do Python, but you can also throw up R and Rust. And I've not tried it, but apparently you can also use C++ in there as well. And it really helps simplify some of the workflows that might be using just one component, say from an R. Someone's written something in R that you want to pull in, so you can start to build relatively complex configuration files that allow you to pull all of those things together. And as I said, it's very portable. I've had it now on a local desktop machine, and I've had it on a remote server as well, and it seems to be handling everything okay. Been through some of this, but I guess the main message is that it's very easy to use, and it simplifies the install of all of the packages. And it really helps, particularly when you have other data scientists, sort of geospatial data scientists, or people with little geospatial knowledge on your team, and you're trying to just get everyone using and developing around the same code. So I would say it's time for everyone to start at least having a look at Pixi. Maybe using Pixi is taking it a bit too fast, but certainly have a look at it. If you're interested in reproducible science, with the increasing complexity of geospatial workflows, start simplifying some of the dependency management by using Pixi. It uses the conda forge repos, which are pretty well maintained, particularly for the geospatial packages as well. And it is open source, although it's backed by this company, prefix.dev. So it would be nice if more people outside of Prefix could also help maintain it as well, I guess, to make sure that the project has some longevity. But it's overall very intuitive and has a familiar syntax. So whilst I was looking around at tooling for that, I just came across an IDE called Positron. So this is just a bit of an aside, but Pixi drops into Positron really easily. Basically, it's a VS Code fork that's done by the guys who wrote RStudio, and they've updated RStudio to enable Python to come in and do all the various things you can see here with little, it's like a cross between Spider and RStudio, if you know what those two are. But it picks up the Pixi environments much more easily than VS Code does. So it's worth having a look at. You can install most of the same extensions that VS Code has as well. Cool, thank you very much. That's dangerous. No Python.
Careless.
Hi, yeah, I have to admit, I haven't used it or seen it, to be honest. Does it replace Python virtual environments? As in...
So the question was, does it replace Python virtual environments? So it could do, I guess. Yeah.
It would do. You
yeah.
install it system-wide, right?
Yes, yeah.
And then on a particular directory or project, you then go into that.
Yeah, so it gets installed system-wide. Yeah. Then you would go into a specific folder, then do Pixi init, and that sets up an environment within that. And you can then have more than one. So you could have a development environment, a production environment, and then, I don't know, a testing one as well. So you can set up multiple environments, but they're all held within that single folder.
Yeah, and then if you wanted to back out and go to a different project, which is pip virtual environment based, you just
you can just do that, and you can run pip as well through Pixi as well if you needed to. But I don't know about the complexities of that.
That sounds like a bad idea.
Yes, yeah.
It usually is when I do that.
I've just started using that. Mentioned something I always struggle with is you've got the system dependencies, but then you've got R packages as well. No CondaForge has some R packages available, but some that are. Have you any experience with that? Like, how do you handle that? Could you handle that with Pixi, or is it just a case of packing?
So the question was about how you handle R packages using Pixi and CondaForge. So I don't have any experience. I'm not really an R user at all. What I've seen online is that they've only used the packages that were in Conda. At least that was my understanding of how they were doing it, because they were just basically doing a Pixi add, and then it was whatever the R thing was. So that would definitely be an interesting thing to look at. Yeah. Sorry.
Yes.
Yeah. You mentioned that it was installed system-wide. Can it then cope with having multiple different Pythons?
Yes.
Maybe more Mac issue.
Yes. So the question was, if it's installed system-wide, can it cope with more than one Python? So yeah, I think I've got 3 different versions of Python on my laptop, and then you can drop in, specific to whichever Pixi environment you're using, additional versions of Python. So it holds everything within the environment, within the folder. So yeah, it could get a bit big and unwieldy, I guess. But hey, I'm just a user of geospatial data, so it doesn't bother me.
You've already got loads of data.
Yes.
CondaForge is the channel there. If you're in an organization that has an internal scan for security, any point to internal repositories.
So the question was, can you use your own internal repositories? That is very interesting. No idea. Sorry, I don't know. It's not a use case I've come across, and I've not seen anything mentioned about it. But it'd be worth looking into.
Paul?
I might be about to answer that question.
Oh, cool.
As far as I know, you can connect it to any channels that are running the C flag. So anything that Conda or Mando can access.
Okay. So
it just defaults to Conda.
Excellent. So the answer is yes, you can.
Going back to UV, recently, you're getting started, not very much like it translated exactly to UV. So I'm curious to know, having not gone maybe as deep as you have, where did you find UV stop working? Where did it where did it fall apart?
Installing GDAL was the main problem.
That was where I got to.
It just got too messy, and I thought, bugger this, let's see what else I can find. And I came across Pixi, and because, to be honest, the entirety of the talk is just how do I install GDAL without it messing up everything.
Any idea how prefix.dev funded, or whether they might go about it at any point?
No,
that would never happen with an open source project.
Question was about how prefix are funded and their longevity. I'm not sure. That is a concern of mine, is that if I get into this, then I've ended up getting into something that could disappear. And the same with the positron thing. I mean, Posit have been around long enough that maybe they'll hang around, but yeah, I don't know. I'd never come across prefix before.
Any sign of any AI influence
No, which is nice. No AI. Hooray. Yes.
Have you looked at any of the container resolution like Docker or something like VS Code has its own containers where you can run the environment? Like, have you looked at that as well, or just like from UV to Pixi?
So the question was whether I've looked at containerization. So no, unfortunately, I haven't. No,
Never mixed things.
yes. So yeah, I've only run it natively. I've not looked into whether or not it does things. I think there's something on the prefix website about containerization, so I think it handles it in some way, but it's not in my use case, so I haven't really looked.
Yes.
So the VS Code support isn't that great. Is Pixi relatively new? So would you expect it to get better VS Code?
So questions around VS support for Pixi and VS Code. So when I installed UV, basically I could then open up VS Code and it just found the UV environment and I could run all my code and that was fine. And I assumed it would be the same for Pixi, but it wasn't. You basically you can hard code in the environment so that it finds it and runs it, but it wasn't as nice as Positron, which it just turns up and you can choose from the list of various different environments that you might want to run. I was also, there is an extension in that's being written for Pixi, but that sort of got so far, and then I think either the developers lost interest or they've not got any money or something, but it doesn't quite do the thing of allowing you to run the environments in the way that I, as a non-programmer, would want to. So the question is, did I switch to Positron just because of Pixi? Yeah, sort of. Yeah, pretty much. I like nice, easy workflows where I don't have to think too much. So yeah, it was partly that, and I also like shiny new things.
Cool. More questions? Right.
How long does it deal with upgrades over time, or have you been using it long enough to know that, like GL upgrades, etc.?
It seems to handle it pretty well. Sorry, the question was about how does it handle upgrades. So it seems to handle it pretty well. I've updated a couple of projects a couple of times, and nothing's broken. So in my mind, that's a win. Yeah. Yes,
better than usual.
Yeah. So it seems relatively robust. It seems pretty easy to use. I mean, it's worth having a look at, definitely. I would say.
Okay. Applause for Alistair.